Welcome everyone to Listening to the Wind, IWSA's regular interview series. And I'm delighted to say today I'm sitting with a real pioneer in our wind propulsion sector, Marc Van Peteghem. Marc, welcome to Listening to the Wind.
Thank you very much to welcome me, Gary.
It's my pleasure. So I'm going to just quickly introduce Marc for some of those of you who don't know him. Marc is a naval architect and co-founder and managing director of VPLP Design Studio since 1983, and a co-founder of AYRO, the company commercializing the Ocean Wing, which is just right behind you there, a wing sail system for commercial shipping. So without further ado, Marc, I'm going to hand over to you to show your presentation, and I will come back on the other side of that. Okay, Marc, over to you.
So I'm going to present you the company AYRO. I'm going to talk about the company, the system itself, and where we're up to, the study that we are developing at the moment. Few numbers that everybody knows, I think, about shipping, the importance of the shipping in the international trade, the share of the CO2 emissions, and of course, the new, the regulation targets set by the IMO. There are different possibility of savings emission. Of course, you can clean the fumes by using scrubber, using LNG or different less greener fuel. But there are also ways of saving fuel. One of them is, of course, working on the hull, the propeller, and the other one is using the wind, which is totally free, of course, energy. And here you have the shares of each saving that could be done, and you can see that the wind is take a big share of that. Thanks to the technology, we can use the wind now we know how to make a simulation, and of course we can study for different ship the best technology, the best routing, and that's a very good way of predicting. Then we can control the system, which is very important as it has to be totally fully automotive. And the new manufacturing technologies allow us to build strong and resilient and light systems. The company. In 2010, VPLP designed BMW Oracle, who won the 33rd America's Cup with this giant wing cell. And that gave us the idea of, maybe saying that this could be a good way to decarbonize shipping industry. In 2016, we built a prototype on a small trimaran that show us that the system was viable. 2018, 2019, and still sailing. We built two wing sail on the Energy Observer, which is a zero emission catamaran, which is still sailing around the world. And 2020, VPLP designed Canopy, which is a RoRo that will deliver the elements of Ariane 6 rocket from north of Europe to French Guiana. And on this RoRo, we set 363 square meter wing cell that allow to save up to 30% of the fuel. AYRO is a spin-off of VPLP. AYRO benefit from the expertise in speed analysis and all the software that has been developed by VPLP to analyze the performance of the racing boat that we can use also for shipping. And that's how we could analyze and design canopy. We also have in-house expertise in shipping and the industry. And because we have all the talents in-house to do so. With myself, there is Ludovic Gérard, which is our CEO. He spent 22 years at CMA CGM as he was president of the shipping sector for CMA CGM. Giorgio Provinciali, who is our CTO, is a long career in America's Cup, and he's been working with us for many years. Carrie Meadow, CEO, coming from the industry, and Romain Gransart, head of business development. What we do is we can start from, as I said, with using our very high-end software, predict the performance and make simulation on different routes of depending on the ship type and also the route, and on new build and on retrofit. We can also after that we can deliver the ocean wings and the software that goes with it to trim the sails automatically, which is called AYRO. And after, of course, we offer installation and training, maintenance, and data services. This is our industry in Caen along the canal, where we can assemble the wings. And as we are along the canal, we can ship them directly or install them on a ship. We've been through a fundraising, and we achieved to raise 10.5 million euro. Our investors is Ocean Zero from the United States, BPI, which is in France state bank, and Merinvest, France also. The system itself, we've been looking at all the different kind of vessel, and we are able to install an ocean wings on any type of vessel today. How does it work? Well, there are sensors that measure the wind direction, wind strengths. The computer analyzes the data and send the information to actuators that adjust the wing cell to the ideal camber and incidence. Our system is a two-component wing cell. It has a main element and a flap. It's twice as performant as a traditional rig. It's fully automated. The incidence and the camber can be adjusted, and it's reefable and furlable. One of the big, so the main the wing that we've developed at the moment is 363 square meter. The footprint is comparable to a handling crane setup, and it's also the same kind of loads, and there are electrical actuators. It's simple, reliable, safe, and performant. The AYRO software interface with all the components of the ship, of course, optimizing the route through the ocean, but also interfacing with the engine, the propeller, and also the energy on board to make the best optimization between the ship and the use of the wind. As I said, our system is reefable and furlable. It's light and compact. We have systems to tilt it, to move it. There is no issue of stability on the ship. It has a limited footprint on the deck, which is very important. And it's extremely versatile to windnaggle. And this is also very, very important. It starts to benefit at 5 degrees of apparent wind angle, which is very important because as the wind angle are very, very often quite close to the course. The canopy project, 121 meters long, is going from north of Europe to French Guiana and back. The design speed is a little bit above 16 to 17 knots, but and the fuel saving, of course, depending on the speed and the wind, is between 20 to 35%. And the canopy is under build at the moment, and she will be delivered at the end of the year. We've worked on a system that could be adapted on a container vessel, which is, of course, a little bit, it's not the ideal setup, of course, but we managed to find solutions to retrieve the wing cell in pockets and allow the commercial service to operate without any major change in the operation, which is very important. How do we proceed? First thing is to work on the performance. Of course, it depends, as I said, on what the commercial route which is followed, and the ship itself, and we use analysis of the weather for the past few years back. So it's based on real weather forecast study. Then we looked at the impact on the ship, depending taking into account, of course, the operation, because it's very important, the visibility, the stability, and the footprint of the system on the deck. Then we look at the structural interface and what should be done in case of a retrofit, to reinforce and also the pedestal that could be fit on the deck. And of course, interfacing all the automation system to the electrical system of the ship. Thank you very much for listening.
Okay, thank you very much, Marc. I'm picking up new stuff all the time. Really comprehensive project, and accompanied you're delivering the whole package, the whole design and the application package. Very impressive. I had a couple of questions around, you've come from the high performance design world, designing beautiful, fast racing yachts. What would have been the challenges of moving that knowledge or bringing that knowledge into a commercial shipping world where maybe we're not going as fast and maybe not quite as beautiful as ships?
Well, of course, the constraints are very different. If you study a racing machine, of course, and especially in the case of the America's Cup, there is no what is a must is the performance, the overall performance. Of course, cost is a second order, and also the capability of retrieving, furling the system was not an issue to keep it as light as possible. So so it's totally different. But one thing is we proved that this system was really performant. We have real data that comes from experience, from real science. And we thought that if we could adapt these systems to the maritime industry sector, it could be very interesting. So what were the key factors? The first one was, of course, to be able to fully automate the system, which is easy because the system is a solid, in a way, system. It doesn't. Then theoretical study could give us the best trimming angles of the system, and starting from that, if we could, and it's easy to do, if we have the sensors that give the wind direction and wind force, the trimming was possible. And second thing was, of course, in our opinion, to be able to furl the system in case of really strong wind to reduce the drag. And the third one, of course, is to be able to industrialize it for a price that is okay for in terms of return on investment and payback. But we will come back, I'm sure, about it. And so the good thing is we know what we have in our hands in terms of performance, but of course we have to adapt it to the constraint of the shipping industry.
Yeah, and that cost issue, the cost points, the price points are always going to be a challenge. Yeah, so. But I noticed I'm very impressed by the location that you chose for the factory. That access to the canal system there. Obviously, there's quite a bit of development going up in the north regions of France, in Nantes, in Brittany as well. So it's a very interesting design. And from what I could see there, you're very close to setting up the operations now. So it's is that correct? Of March 2022?
For Canopé?
For the factory.
The factory, yeah, the factory. Yes, it's we have the keys today.
So you're moving forward, yeah.
Yeah, we do, yeah.
Yeah, and I saw a couple of pictures of the canopy under construction. So the hull is already there.
Yeah, the hull is there. Yeah.
Yeah, and I was just wondering, you selected 4 wing sails or ocean wings on the design. Was there any reason to restrict it to 4, or could you have gone with a heavier wind component on it?
At the beginning, we had 6 wing sail, smaller wing sails, but in fact, we made, really comprehensive studies, and we found that and it's an important point, the interaction between the systems were more beneficial if we had only 4 bigger ones than 6 smaller ones. Of course, on a longer ship, we could have multiple systems, 6, 8, depends on the length. Because what is really interesting is in our system, we have beneficial, in certain angle, we have beneficial interaction between the systems. Not always, of course, there are also less beneficial ones. But so it's not only the performance of one wing cell, what is really interesting to look at, it's the complete power developed by the multiple systems, because it's not like a sum of if the sum of the performance of one system. It's much more complex than that. There are beneficial interactions.
So it's like a pocket of wind, an entire system that is interacting with wind.
Absolutely.
Yeah, fascinating. Now, the energy observer, that was actually, I remembered while you were talking about that, that was the last time we met, back in 2018, 19?
Something like that, yeah.
Yeah, in London.
Pre-COVID, anyway.
Pre-COVID, which seems a long time ago.
Yeah.
But no, I remember I was very impressed coming onto the boat and talking with you there. Lessons learned, fantastic to have that kind of platform out there.
Mm-hmm.
And she's going to some very interesting places, the Arctic. And I was just wondering, are there any lessons learned from that system? I'm sure there are many that you could share with us, just to give us an idea of, how the development has adjusted or been optimized.
Well, the 2 main ones is first the confirmation of the performance. Mm-hmm. So again, we know what we are talking about, and in real life. And the second one is also, on reliability on the systems. Of course, I'm not going to say that we never had any major damage, but little things, that goes wrong. Any sailors know that if something can go wrong, it will go wrong on the ship. So it's very important to have this this real life analysis and experience. So very little things, we've been through also amelioration. Iteration on iteration. Sorry, thank you. Iteration on the AYRO systems. Mm-hmm. We're now at the 12 V12 version 12. Little things, but because we keep, of course, a constant link between the boat, between the boat and the office. So we learn a lot, of course.
And of course, it'll be fascinating once the canopy is operating.
Yeah.
To be able to get some comparative data there as well. Yeah. So looking forward to that. Looking forward to that, for sure. I'm sure you are. Now, I just wanted to move on to a bit of a wider question, but it's connected with what you presented there. Canopy is obviously a RoRo, and especially design RoRo. But then you're looking at container ships as well. Of a system there, and my question for you, which is always a challenge. I got your point very, very clearly there. It's not the lowest hanging fruit; it is a real challenge.
No, sure.
But which of the segments do you see, firstly, being the big growth area for wind propulsion in general, and then more specifically for your system? Where does your system? Does it fit into all segments? Is it something for everybody? Or are you sort of focusing in more on, for example, the RoRo market or another?
As you said, there are low-hanging fruit, of course. RoRo is a very good example of that, of course, because there's not much interaction on the deck, really. But we feel that, you know, raw material transportation, dry, liquid, gas is of course a sector that will develop very well, and there's no big issues. We need to be able to move the systems to clear the deck for commercial operation, but that's ongoing. And container ship, of course, which I think will still be always there, and with need of a quite, you know, relatively fast speed and good quality of service. And also, I think it's very important because it touches one of the constraints. Maybe we're going to talk about it a little bit later, but you know, we feel that the society is really now asking for more greener logistic, and I think. Of course, container ship is the first one on the picture. So it's a real need also to show that you know, it can be done.
No, indeed, and I think, you know, the interaction of most people with shipping. One is, of course, if they go on a ferry, maybe a cruise if they've got the money to. But the other one is, you know, when they think of shipping, they think of the goods being moved. And as you say, it's a kind of consumer-facing segment. And I think the consumer cargo owners, these big retailers, etc., are really starting to push. They want zero emissions or very low carbon feeding in. And do you see that as being one of the main drivers for wind propulsion going forward? Is this public pressure, or will it come more from kind of business to business or policy?
You know, there are two main drivers to change. One is the constraint, and that has to come from IMO. And I think there's one big thing missing is the carbon tax. I mean, when carbon is free, so it will be always less expensive to pollute, and we need a carbon tax, and well, that's really so constraint, and also maybe because you want to change or you see an advantage to change, and I think social pressure, if well understood, for a ship owner, could be a marketing point, a marketing advantage, a concurrential advantage. Starting to go there first and saying, you know, I'm really making effort, not greenwashing, but real thing. And you know, those are the two.
Yeah, sort of a little bit of a carrot and a stick. Yeah, but no, indeed. And I think, you know, what will you say about the marketing side of things? And obviously, I think you're absolutely right. It's got to be a comprehensive, it's got to be an impactful change, not just something on the edge of or a very peripheral change. But it's also, you know, one thing with wind propulsion is it's the most obvious change that you can make to the profile of a ship. You know, if you change the engines, nobody really sees that. But when you put wind propulsion and wind rigs onto a ship, it changes the whole dynamic of what that ship is. One question I have for you around the canopy design and also the trade winds 2500, but especially I think the canopy design is a very, how can I say, it's a very impactful design. It's very striking. And I was just wondering, what kind of reaction have you had from your design colleagues, but also from the industry when they've seen this and they've had this presented to them? What's their reaction?
I just can say one thing. Beginning of December, we went to visit the yard and the construction with a ship owner and some people Ariane and also from the finance sector. And we all share a very big emotion, like being part of something which is really new. The first fully hybrid propulsion commercial vessel at which, you know, has with a level of saving which is really substantial. And that was something between us, you know, that really surprised ourselves, you know? And it was a very good moment, a very good, you know, looking, and also I think it's beautiful to see a ship being, you know, built, its birth, and it's something, it's really something special. That's
yeah, I can understand it, but you know, I'm looking forward to seeing the vessel when she's launched and being there and hopefully feeling that with you. But I think it's really important, and I think, you know, I've been in a couple of meetings recently where people said, well, when can we come and see these ships? When can we see them? Because, you know, they turn around and say, seeing is believing. But I think it's even more than that. Seeing is actually believing in a new future or a different pathway that we can take. So yeah, I'm really excited to see that. Okay, I'm just a little conscious of the time. So just my last question on this is around the rig itself. So just bringing that back a little bit to your design and everything. You've gone with a soft sleeve, if you like, the materials.
Yeah.
What was the selection process there? Because you could have gone with a rigid wing that maybe in some way could retract, or what was the, rather than the reasons you went for that, what was the actual design process there? Well, how did you reach that point?
Well, one thing to know is, you know, as I said, a wing is very efficient, very close to the wind. And indeed, I'm going back a little bit away from your question, but I think it's an important point to raise, because it's I don't think the recent amendment of the MEPC is going in the EEDI calculation is going in the right direction, taking into account half of the maximum force, and it doesn't represent the truth, because the truth is, as a ship has its own speed, the apparent wind angle is very close to the course. And what's very important is to have a very good lift to drag ratio, and to start to push forward even at small angles. And it's not the maximum force which is important, is the versatility and the ability to work close to the wind. But for certain ship, it's important to be able to furl completely the system in very, very strong wind. And that was the case. On very big ship, it might not be necessary. As a wing sail at 0 degree is dragging less than a tube of the same width. So retrieving the sail is also very useful for commercial operation. You know, you furl the system and then you orient the boom in the way that doesn't goes in the way of the commercial operation. And that was one of the criteria for Ariane.
Yeah, no, makes sense. Yeah, makes sense.
So we will adapt, in fact, the system to each use. It could be in some way, it could be, for instance, on a container ship, we could fold the two the main element and the flap together, and retrieve it in the casing, which in that case we don't need to furl it. So
yeah, I've got you. Yeah, so there'll be refinements, changes, adjustments. Yeah, and I think. And I think that will be the case, you know, with the circular that you're talking about around EEDI and EEXI. I think as more reference vessels, as more data becomes available, there'll be refinements there. There'll be options, additional options being brought in, I think. Or it's always a challenge, I think, when you have a limited number of reference ships there to get everything spot on the first time around. So yeah, but. Please go ahead.
No. So maybe talking about that, you know, in for smaller ship, for instance, the fishing industry, you know, for deep sea fishing boat, the impact of the fuel cost is terrible on their benefit and their margin. So at a certain time, I think using the wind may make a lot of sense for them. Just maybe they would need help to pass the threshold, the necessary investment. But for smaller ship like that, being able to retrieve the system is very important.
Indeed. And I think actually that touches on my sort of final, or my final sort of discussion point was, I know that you have been very passionate around the NGO that you contribute to, whatever.org, with Eve and over in Bangladesh, and designing systems and ships for least developed countries. And I'm just wondering how you feel, because, you know, obviously fishing vessels, a huge number of fishing vessels in developing countries. How do you feel that the wind systems that we're developing mainly in the developed world will actually filter through to least developed countries, where, frankly, right now, the only option is to put a diesel in to a vessel. There's very little other option. So I'm just wondering how you see that develop.
Well, in a context where it's less expensive to pollute than to make any effort, there is no solution, because everybody will go for the cheaper solution. It's so important for them. So they won't change. So they would need help to change. That's for the fishing industry, as I saw it, you know, in Bangladesh, or even in the Indian Ocean, I know and all of them. I mean, they will need some help to pass this threshold. But also, you know, when you look at inter-island general cargo shipping, we worked on projects for French Polynesia. We looked at projects in the Caribbean. I mean, it's so obvious. I mean, you can save. There are slow speed. You can save up to 70% of the fuel. But as they are slow, their speed is very slow. It's always important to relativize, to look at when you talk about propulsion, for those low speed boats, 70% of saving looks a lot, but in terms of money, in economy, it's difficult for them to. I mean, the payback on the system is very long. So today the game the game doesn't push people to move.
Yeah, no, and of course, you know, having some form of carbon pricing in there is going to make a difference. You know, something that IWSA has been looking at around the Norwegian NOx fund, you know, bringing that money back into the industry and funding some of these projects and getting those costs down, would make a huge amount of sense. But that's up to the politicians. I don't think we don't get to too much of a say on that. But that, Marc, fantastic. What I'd like to do now, just to couple of quick fire questions for you. So these are like, you know, one sentence or a phrase answer. So how did you get first into wind propulsion? And the second part of that question is, and then why did you start looking at commercial wind propulsion?
I'm afraid it's going to take a little bit longer. At the turn of the century, I got really aware of the threat on humanity because of the climate change. And you know, there are two ways. You can be optimistic, pessimistic, but that's a spectator point of view. And I decided to be an actor. So I co-founded whatever with Yves. And then I co-founded a design school called Design in Nice, which is dedicated to sustainable innovation. And of course, this idea of AYRO came as kind of naturally, because that was the heart of our business. And then to develop really a system like that on an industrial size, we set up a company dedicated to that. So I've been dragged into that in a way, you know.
So it's been a voyage.
Yeah.
Yeah. Interesting. And if you could go back 20 years to that man that was suddenly waking up to, you know, really understanding or really appreciating climate change and the threat there, and what you started, what advice would you give yourself 20 years ago when you first started these things?
What was?
What advice? So if you could get in a time machine, go back to the turn of the century, and meet yourself, what advice would you give yourself now?
I would do the same thing. Never give up. I have 5 kids, so there is just one thing to do, is to act and to do whatever we can. So it's of course I didn't realize what was in front of me. But I'm very happy to have done it, and it's a constant challenge with a wonderful team of young, great, dedicated, people, to actors willing to change the maritime industry and the climate, and to act for the climate.
I get that completely. I mean, I'm very privileged that I'm surrounded by people in so many companies like this, and just looking at the expertise in VPLP and AYRO is fantastic. I'm going to ask you 2 very quick questions. What is your most frequently asked question about the AYRO? What do people want to know?
Payback. One word.
Number 1, number 2, and number 3. Yeah.
Payback time.
Right.
And it's strange because it's payback. It's not a question of you can't really class. I mean, the payback is one element, but if you look at of what is in front of us in terms of probably change in regulation and all that, what's important is the performance of the system, because on the long run, it's much better to have maybe a little bit longer payback and a system that will save much more in the future. So we face an industry which has a culture which is quite difficult to understand from my point of view, and I think the bigger change is in people's mind. In fact, technologically speaking, where I think there are multiple systems, which is a very good thing because there is space for everybody. I'm really believing in that. I'm so happy that there are so many solutions available on the market, really. But you know, we all face the same payback. Is not the only question.
Yeah, no, indeed. Although, you know, I would say the last few years, I've seen a change in the boardroom. Guys who, you know, 3-4 years ago, the boardroom was like, oh, we're not really that bothered about climate change or emissions. Yeah, we'll comply. But I have seen some quite dramatic change. And for shipping, which is generally seen as a bit conservative, some pretty big changes, new blood coming into the boardrooms, and the guys get it. They've just got to find that commercial lever to be allowed, you know, to do the right thing in the sense. Yeah.
The young generation.
Younger than me, at least. And I was just wondering, okay, this is a question I ask everybody on the thing, is around the life cycle analysis around the carbon footprint of the systems becoming a bigger thing in the industry now. And have you been working on that to assess, you know, your impact from all the materials, etc.?
Yeah, it's an ongoing process because it's always difficult to have the real analysis from our supplier sometimes. And we are, our ring cell is in composite. So composite is a bit, we can't go faster than the industry, but we know, I mean, the chemical industry, but we know there are big progress made, you know, to be able to recycle the fibers from the resin and all that. So it's the same for the yachting industry. So we are following this very, very closely also. The soft envelope, the soft skin is fully recyclable. So that's one thing. And the rest is electrical and mechanical components which are recyclable. So it's an ongoing process because we can't have precise value, accurate values today, but we are working on that because it is very, very important, of course.
That's fantastic. And my final question, which again is one that I always ask, is: are you recruiting at the moment? You know, this is you're expanding. You've got a new factory. I'm sure many of your personnel have moved as well. Yeah,
we are recruiting, of course, and it's quite difficult. It's quite difficult because there is a tension on the market. But we have, as I said, a wonderful team of young people, and it's growing almost every week. And we are recruiting.
Yeah, well, that's good. That's the right direction. If you're having trouble getting the people, I think in our sector at the moment, as you say, there's many systems being developed and companies growing. There's competition for the talent. So I think that's in a sense, it's a nice problem to have, but not so nice when it's happening to you.
Yeah, sure.
Yeah,
that's true. But yeah.
Well, Marc, I think we could probably sit here all day and talk about many more facets of this, but I'm conscious of taking too much of your time, and also, you know, the audience would like to hear, a takeaway. What should they take away from our discussion today and about AYRO and about VPLP? So I'll hand that over to you, Marc.
About AYRO and VPLP is just that we are working on a system that we know very well for many years. So we know exactly what we are doing, studying, and when we're talking about values, it's proven real values of load and usage. And in general, and for all the systems, again. We all hope that something will happen that make you know, the carry on polluting because it's cheaper is something that that hurt me really. And I think I don't know where it should come from, but I don't think it will be sustainable for very long. So something has to be done, right? It's totally, of course, out of my hands. It's probably out of yours, but we all need. So maybe it could be from the society, from social pressure.
Indeed. Well, I think your expression about not being a spectator but being an actor, I think is a really it's an important message there. That's what I'm taking away from this. Yeah. Everything else, all the beautiful boats, the technologies, but being an actor, not a spectator, is incredibly important, and in our sector too. So, Marc Van Peteghem, I'd like to say thank you very much for joining us.
Thank you, Gavin. Thank you. It's been really nice to talk to you.
It's my pleasure. And thank you to the audience for joining us for this Listening to the Wind episode. There will be another one coming in the not too distant future. And I'm sure that Marc would be happy to answer, Marc or his team will be happy to answer any follow-up questions that you have. And of course, IWSA is always here to help and assist wherever we can as well. So without saying anything more, thank you very much, Marc, once more.
Thank you.
I'm going to use my French here, bon voyage.
Thank you. Belle journée. Thank you.